Welcome to LID Academy, and in this video we are going to continue calculations using the idea of beta functions, and specifically in this video we are going to be dealing with trigonometric functions. So before we continue, there are some formulas we need to know. Beta of mn equal 2 integral from 0 to pi over 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta. So what we want to do is that mostly we'll be using this formula. We would like to make the coefficient of the integral sign 1. So dividing both sides by 2, we are going to get half here, right? So we are going to write the general formula for for evaluating trig functions under beta, and using the idea of beta functions. So this formula was derived from the general definition for beta functions. So I think that is it. So like I said earlier, we'll be dealing with trig problems. So this is one of the formula that we need to know. Another formula we need to know is the Euler's reflection formula, and it's stated that the beta of n, 1 minus n should give us pi all over sine pi n. So these are the two formulas you need to know. So have beta of mn equal integral from 0 to pi over 2 sine 2n minus 1 theta cos 2n minus 1 theta d theta. So now let's continue. Evaluate integral of 0 to pi on 2 d theta all on square root of sine theta. We have to evaluate this. So one thing that will come into our mind is that as far as you see the integral from 0 to pi on 2, there is a clear hint that we can use the idea of beta function to evaluate this problem. Remember that the beta functions are very important because they help us to evaluate in some integral problems with ease. So, and this is one of the advantage of beta functions. So you know that for the formula for evaluating beta functions that are in sign form is just this: have beta mn equal integral from 0 to pi on 2, and that. So now we are trying to find a way of massaging our problem into this form so that we can just compare exponents and then look for our m and n, and we then follow by finding our half beta of m and n. So now let's continue. So you can see that from this problem, I can read out this problem as integral of 0 to pi on 2, 1 on square root of sine theta d theta. Is that the same thing? So this square root of sine theta, I want you to write it in a way that will help me solve my problem very easy. So this is just the inverse of square root of sine theta, right? So from general math, we know that 1 over s is the same as s to the power negative 1, right? So 1 over s to the power 2 is the same as s to the power negative 2, just the inverse. So I can follow up by saying integral from 0 to pi on 2 sine theta, right? And square root means to the power half. Square root of any number is the same as that number raised to the power half. It doesn't matter whether a number or a variable. So square root of that thing is the same as that thing raised to the power half. So this is raised to the power half here. Because I'm bringing it up, removing the inverse sign, is going to be minus half d theta. So now I've massaged my problem into this form. Sine theta raised to the power minus half. It should be sine raised to the power minus half theta, right? So the theta, let me write this one. Let me write it here. Sine to the power minus half theta the theta. And I want my problem to be in this form so that I can go ahead and compare exponents. But now I can see that this problem involves only sine, no cos. So it means that comparing this to the general formula, which is half beta of mn equal integral from 0 to pi on 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta. I want to compare the powers of the sine term and powers of cos term. And now the power of sine here is minus half. So 2m minus 1 equal minus half. To look for the value of m. So 2m minus 1 equal minus half. So multiplying this 2 by 2, I'll get 4m. 2 by minus 1 minus 2 equal minus 1. If I multiply here by 2, I guess minus 1. So this minus 2 should cross. So 4m equal minus 1 plus 2. My 4m equal positive 1. So my m here equal, dividing both sides by 4 gives me 4. So now I don't have a term for cosine. So I'll just equate 2n minus 1 to 0. If there is no term for that, if there's no corresponding term, just equate the exponent to 0. So 2n minus 1 crossing gives me 1. Dividing through by 2, my n equal half, 1 on 2. So now that I know the value for m and n, m right here and n right here, I know that half beta of mn and my m is what? 1 on 4. So half beta of 1 on 4, my n is what? 1 on 2. 1 on 2 to give me integral of 0 to pi on 2 sine minus half theta d theta. So now I just ignore this and use and solve for this one. The value that I'll get will be the solution for this whole problem here. You see what beta functions has brought to us? Just giving us an easy way to solve problems, integral problems. So let's go some integral problems. So an important thing to know is to know how to evaluate beta functions too. The normal beta problems. So from the formulas, I forgot to add one formula, which is the relation between beta and gamma. So relation between beta and gamma is as beta of mn equal gamma m gamma n all divided by gamma m plus n, right? And yes, so we are going to use this expression to evaluate beta of 1 on 4, 1 on 2. I don't want to write down this. I want us to continue with this later. So we know that the relation between beta and gamma is that beta of mn equal gamma m plus gamma n. Sorry, multiplying gamma n is not a plus. All on gamma m plus n. So now beta of 1 on 4, right? Let me bring the half. Half 1 on 4, 1 on 2 equal gamma 1 on 4, gamma 1 on 2, all on gamma 1 on 4 plus gamma 1 on 2. So adding the denominators, simplifying the denominators. The denominator, what am I saying denominators? So 1 on 4 plus half gives us what? So that will be 3 on 4. So gamma 1 on 4, gamma half. And what is gamma half? We know the gamma half is a constant, which is square root of pi, right? All on gamma 3 on 4. And don't forget that we are multiplying everything by half, right? Let me write this here very well. So we are multiplying everything by half. So we know that gamma half is just square root of pi. So we have gamma 1 on 4 square root of pi all on gamma 3 on 4. And what is gamma 3 on 4? We also have to evaluate that. Well, it turns out that when we are trying to evaluate a gamma function and we are getting a negative value, we can just leave it like that. There's no harm in that. So, but let's see how we can do this. So for gamma, since it's a fraction, we have to use this formula. Gamma of n plus 1 equal n gamma n. And we want to solve for gamma of 3 on 4. So gamma of 3 on 4. So we want to find a way of getting a number that we can add, let's say a number n. If we add 1 to it, we'll still get 3 on 4. So a number that we add 1 to it to get 3 on 4. And a simple way of doing this is just form a basic equation. So equate this to that. So n plus 1 equal 3 on 4. So 3 on 4, simplifying this, we are going to get, multiplying 2 by 4, we'll get 4n, 4 by 1 plus 4 equal 3, right? So 4n, this one crossing gives us minus 1, right? So we divide both sides by 4. So it's giving us minus 1 on 4. So since we are getting minus 1 on 4, we can just leave it like that. So if it were to be a positive number, then we are going to say this one is just equal to 1 on 4 plus 1. Then we'll go ahead and compare our value to the formula. Here our n is what? 1 on 4, and then it's called 1 on 4 plus 1. So 1 on 4 plus 1 equal n factorial gamma n. So our n here is 1 on 4. So it's going to give us 1 on 4 gamma n, which is also 1 on 4. So since we are trying to evaluate it and we are getting a negative number, which means we have to, let's say, the thing will turn out like it will turn out negative 1 on 4 plus 1. So once you are seeing this, just leave it like that. Your answer is recommended to be in that form. No problem if you leave your work, unless you feel like working extra. Okay, now that we are getting negative, so we can just leave it like that. So let's see what we can do to gamma 1 on 4. So an easy way I like using to evaluate things like this, that just write 3 on 4. Let's say we have to find gamma 1 of 3 on 4. So 3 on 4, punch it on your calculator, subtract 1 from it. Since we are getting negative number, just stop. If you are getting a positive value, you write that one and subtract 1 again. The fraction that you get, you write it. So you continue like that out to a point that you get half, or you get a negative and then you stop. So let's do the same for 1 on 4. So 1 on 4 minus 1 is also giving us a negative number, so we can just leave it like that. Once you subtract 1 when you are getting a negative number, you can leave it like that. So this is going to give us half. We have half multiplying. Let's rearrange this term. So let's bring gamma square root of pi here, gamma 1 on 4 all on gamma 3 on 4. So since these are just multiply, we can rearrange our answer to be in this form: 2 gamma 1 on 4, all on gamma 3 on 4, right? So this should be our final answer for this problem. So square root of pi on 2, gamma 1 on 4, gamma 3 on 4.